All right, Matt 2, here we go. We got lesson 8.3.2, ratios of similarity. All right, 8-64. Alice has a 4-inch by 5-inch photo of the girls' championship ice hockey team. Okay, so from the last problem. The school's principal wants to enlarge the photo to display it in the main hallway. So he wants to take a 4 by 5-inch photo. So it's going to be 4-inch by 5-inch. Maybe it goes the other direction. I don't know. And they want to display it in the main hallway. All right. How much do they want to enlarge it by? Oh, we don't know yet. All right. Alice goes to the local print shop, and she has many choices of frames: 7 by 9, 8 by 10, and 12 by 16. But she wants to choose a frame or a size that's not going to cut off part of the picture. Because when you blow up a picture, you don't want to blow it up so that it's not proportional, because then all the people's faces will look weird. So you want to blow it up proportionally. If you double the size of this side, you want to double the size of that side. So if I do 7 by 9, that's not in the same proportion as 4 to 5. Like, what number did I multiply by to go from 4 to 7? To go from 4 to the 7, I should be multiplying by, what, 7/4. But to go from 5 to 9, I'm multiplying by 9/5, and 7/4 is not equal to 9/5, so that wouldn't work. Now the 8 by 10, that looks like that one's going to work, because I would double the size of this side, and I'm going to double the size of that one, so the scale factor would just be 2. For this one, looks like I'm tripling the size of this one, but then I'm not tripling the size of this one. So that other one doesn't work. So it looks like an 8 by 10 is going to be the best one to use. So she should use an 8 by 10 because the scale factor is 2. All right, the cost to print Alice's 4 by 4 photo is 45 cents. Okay, so the cost is probably going to be based off of the area, how much actual photo they're doing. It's not going to be based off the length and the width, because that's not as descriptive as the actual area that the photo is taking up. So they're going to base that off of that. Assuming that the cost per square inch of the photo is constant, how much should it cost to print the enlarged photo? Well, let's look at this. So 4 by 5 inches, that's 20 square inches. So it's going to be 20 square inches, and it's going to cost 45 cents. Now remember from the last lesson, even though we are in a ratio of 2 to 1 with a scale factor, when we start talking about the areas are not going to be in the same ratio. This one has 800. No, 80. So the area of this one is 80. That's not doubling. That's multiplying by 4. So if I'm multiplying by 4, I'm going to have to multiply this cost by 4 as well. And we could do cross products on that, or you can just see that 20 times 4 equals 80. So 0.45 times 4 should be $1.80. So it's going to cost $1.80. And the reason is because even though the scale factor is 2, the area ratio is not 2, it's 4. So I'm going to take the original of 0.45 compared to the cost of the enlargement, and that's a ratio of 1 to 4 for the areas, because price would have more to do with areas than just the length or the width. And here we can see if we do cross products that we do get x is equal to 180. Vice principal has already made an enlargement of the photo, and he paid $720. How big was the enlarged photo? Okay, so we want to know the size of the enlarged photo. So if I do 20 over x, so this is the original over the whatchamacallit, the copy or the enlargement. So I don't know how big the copy is going to be, but I do know that originally it cost 45 cents, but now this guy's paying $7.20. So if we do cross products here, we would do 0.45 x equals, was that 1440? 7.2 times 20, yeah, 144, not 1440, 144. So we'll divide by 0.45, and we end up with 320. So that's how big the photo is. How many times bigger is it, though? We know that the area, when we compare 20 to 320, that looks like it's 16 times as big. So if I go from 20 to 320, I take 20 and multiply by 16, our area ratios goes from 20 to 320. That's a ratio of 1 to 16. Are the sides also in a ratio of 1 to 16? And the answer is no. The side ratio, remember, is the square root of these. So the side ratio would be 1 to 4. Square root of 1 is 1. Square root of 16 is 4. So the vice principal quadrupled the size and then had to pay $7.20. So the price doesn't go up by 4, it goes up by 16 because the area is always the squared scale factor. All right, we got a few problems here. We're getting close to being done. We're going to analyze the pair of similar shapes, find the ratio of the sides, the ratio of the perimeters, and the ratios of the areas. Okay, so sides, perimeter, area. Okay, looking at this, I'm always going to compare the first one to the second one when we do it. So the first one's going to go on top, the second one's going to go on the bottom. So I've got 15 over 25. Now we should probably reduce that. 15 over 25, 5 goes into both of those. It looks like it's a scale factor of 3/5. So looking at that, looking at the sides, I've got 3 to 5. So if it's 3 to 5, we know that we should probably have over here. Yeah. So over here, we should also have a scale factor of 3 to 5. So this would be 6 to 10. Because that also reduces to 3 to 5 over here. So if I'm looking at my perimeters, I got 6 and 15, that's 22. And then I got another 6 and 15. 22, how did I get that? It's 21. And then this one also give me 21. So that's going to give me a perimeter of 42. That's my perimeter. Here I've got 10 and 25, that's 35. And then over here I've got 35 and 35, or I got another 35. So that's a perimeter of 70. And these are actually in a ratio of, what's it called? It's in a ratio of 3 over 5 as well. Because I can see that, let's see, 14 goes into both of those. 14 goes into this one 3 times, and it goes into that one 5 times. So yes, that is in a ratio of 3 to 5. So the perimeter has the same scale factor as the sides. But remember what we said about the area? It doesn't work like that with the area. We would square the top and the bottom. It would be in a ratio of 9 to 25. All right, next one. This is a 30, 60, 90 triangle. This one has the hypotenuse. So remember, this is A root 3, 2A, so this would be 12. So comparing the sides, It looks like I've got 12 on the first one and 4 on the second one, comparing the corresponding sides. So the sides have a ratio of 3 to 1. The perimeter should have that same ratio, 3 to 1. The area should be these two numbers squared, 9 to 1. Next one. I mean, we can prove this, but we're not going to. Next one. Looking at this one, looks like this one has 5 and 40. So if I reduce that, the sides are in a ratio of 1 to 8, comparing this one to this one. The perimeter should have that same exact ratio of 1 to 8. The area should not have a ratio of 1 to 8. It should have a ratio of 1 to 64. So this one would have 64 times as much area as that one. All right, we good so far? Let's move to the back section. Here it is. All right, Alice finds out that another print shop makes photo enlargements for 0.5 cents per square centimeter. All right, that sounds pretty cheap, 0.5 cents per square centimeter. She wants to see if that's a better deal than what she was getting over at the other print shop. So since they're in cents per square centimeter, they're in a unit rate, we want to go ahead and get a unit cost or a unit rate for the other ones that was cents per square inch. So we found out on that last one that it was 45 cents. Oh, it's just 45 because we're in cents. 45 cents per. And then it looked like we had a squares, 20. So the area was 4 by 5 on the original, so that's 20. So if I do 45 divided by 20, so this is 45 cents over square inches. This will give me a unit rate of the cents per square inch. So 45 divided by 20 looks like 2.25 cents per square inch. So this is only half a cent for a square centimeter. This one's 2.25 cents per square inch. Well, we're not in the same units, so you still can't really compare those two. So what if we knew that there were 2.54 centimeters in 1 inch? How many square centimeters are there in a square inch? Well, if I know that there are 2.54 centimeters for 1 inch, this is the side length being compared. I would need to square both of these to find the square comparison. So 2.54 times itself. The area should be 6.4516 over 1 inch squared. See, since now we're talking about area instead of talking about side length, we would square both of these numbers. So now I know that 6.4516 centimeters squared is the same as 1 inch squared. Which is cheaper? Well, let's find out now. We've got 2.25 cents for every 1 square inch. Why did I do it like that? Let's just do inch squared. All right, I want to convert this into cents per centimeter squared because here I've got cents per square centimeter. So I'm going to write 1 over inches squared over 6.4516 centimeters squared. Now the inches squared cancel, so I'm doing a conversion here. I multiply going straight across, and now I've got 2.25 cents for 6.4516 centimeters squared. Let's just take out our calculators and look at that. So 2.25 divided by 6.4516, it comes out to 0.3, let's call it 5 cents per centimeter squared. So we're actually getting a better deal. This other place was offering half a cent per square inch. We were actually getting 0.35 cents per square inch. So units matters quite a bit. The end. All right, math hard. See you later. Bye-bye.